transport of these chemicals, the most obvious one is when they were used as aqueous film-forming foams. So there's a fire training area, or maybe there was a real incident. Chemicals get sprayed, it's a foam, and then it slowly percolates into the soil, and then of course it doesn't stop, but it goes further and finally reaches the drinking water, groundwater. And then of course it gets pumped back up and gets into our supply, unless you have filters in place. Filters either by the drinking water supplier or in your home. So that's the most obvious pathway. But of course there are more. Some of the stain repellency is conferred through these chemicals, and sometimes they are volatile, so they can actually get into the atmosphere, and then we can either inhale them or they get onto surfaces and that we pick up with our fingers, and that way it gets back into our food and our mouth. On a global scale, again, those compounds that can get into the atmosphere will travel long distances and reach actually the poles, so it's a global distribution. Eventually there will be some reactions, and the result will be that P4 or PFAS will end up as the end product, and so that's how they reach faraway places and then contaminate what we think of as remote and clean regions. So the typical production volume of these chemicals is around 10,000s of tons a year. PCBs were produced at 100,000 tons a year for comparison. If we look in what is present in the ocean water of the Arctic right now, we see similar amounts of both. So even though production was somewhat less, they do transfer up there rather efficiently. We're looking at hundreds of tons of these compounds in the Arctic. We think that most of these compounds indeed end up in groundwater, surface water, and eventually in the ocean, because they're water soluble enough that that would be where they end up being.